Hello everyone, I'm Yaowei Zheng, the founder of LlamaFactory. I'm very glad to be here to the spotlight session of GOSIM AI Paris event. First, let's look at this video. This video shows how to fine-tune large language models with our web UI in 10 minutes. In this video, we select the quant model and choose the dataset to fine-tune. And we can configure the preview the dataset in the page, web page, and configure the LoRa parameters. Yeah. After that, we can launch in the model training by choosing the save path and then click the start button. During the training process, we can observe the training progress bar and the training loss curve. After 12 minutes, we can get the train the LoRa adapter. We choose the LoRa adapter and enter the chat tab to load the fine-tuned model. Then we can see the fine-tuned model, the chatbot of fine-tuned model. We can ask some questions. It is the question. The answer is is aligned with our dataset. Yeah, they can answer the multiple questions in the tab. We can choose the export tab to merge the LoRa adapter to the base model, and also we can upload to the Hugging Face Hub for sharing the open source model. Yeah, the exported model checkpoint can be used by VLAM or Llama for inference or downstream use. So the main advantage of LlamaFactory is that it supports a very wide range of models. It includes hundreds of popular models. You can select the model for fine-tuning according to different scenarios and requirements. And due to our modular design, we can support the model as soon as the model is released. Models we are supported on day 0, including Quant 3, Quant 2.5 VL, and GMAR 3. For the latest Llama 4 model, we achieved adaptation on day 1, and LlamaFactory is the first framework to support the Llama 4 model. To facilitate users in complete model training in different devices, we have integrated many parameter-efficient fine-tuning methods, including low-rank adapter, low-rank optimizer, GLORA, Apollo, and various improved algorithms based on LoRa. Yeah. Therefore, LlamaFactory can achieve pre-training, supervised fine-tuning, RLTF, DPO, and other training methods on consumer devices. Memory management during large language model training is a very challenging problem. Taking Llama model with 8 billion parameters as an example, during the training process, the weight it requires 32 gigabytes of GPU memory to store the weights, and 96 gigabytes to store the optimizer states and gradients, and over 100 gigabytes to store the network activation. So in total, the GPU memory required for training exceeds 200 gigabytes. Therefore, LlamaFactory provides different optimization strategies for single GPU and multi-GPUs scenarios. For the model weights, we can use quantization methods such as GBDQ and AWQ to represent them with low precision float point numbers. And also we can adopt the deep speed 03 strategies for weight sharding. For the optimizer states and gradients, we can use low-rank methods such as LoRa to reduce the GPU memory footprint. Regarding the activation, we have flash attention and gradient checkpointing enabled by default. These techniques reduce the peak GPU memory usage through chunking and recomputation. Soon we will also integrate methods like Ulysses and return to achieve sequence parallelism. Finally, we can even use CPU offloading to relieve the GPU memory load. In addition, we support the use of efficient operators in like a kernel and onslaughts to further accelerate model training. We have replaced the original naive implementations through monkey patching. Combined with the onslaughts, the asynchronous gradient checkpoint strategy, the training performance has been further improved. Through our experiments, if we increase the length of input sequences, the improvement of MFU model flops utilization brought by the efficient kernels become more significant. Meanwhile, since their kernels reduce the peak memory usage, we can observe that the maximum sequence length for full fine-tuning and for full fine-tuning has increased from 4,000 to 32,000, and the maximum sequence length for lower fine-tuning have further increased to 64,000. Through the series of efforts, LlamaFactory provides a one-stop training and inference experience. Users can only need to focus on the construction of data, and LlamaFactory will implement the remaining pipelines. Specifically, LlamaFactory has implemented model training based on PyTorch and DeepSpeed frameworks, as well as the model inference based on VLAM and SGLang. After the model is fine-tuned, it can provide API services, which greatly saves the time for manually building the pipelines. Another characteristic of LlamaFactory is that it provides multimodal capabilities. Currently, we already support data in 3 modalities: image, video, and audio. These modality capabilities come from the operational model themselves. For example, we can use Llama 4 and Gemma 3 for image understanding, Quan 2.5 will for video understanding, and Quan 2 audio for audio understanding. We further support a mixed modality. Both Quan 2.5 or Mini and Mini CPMO can achieve 4 modality training and inference within LlamaFactory. Next, let's look at the video to see how to perform interactive inference in LlamaFactory. First, we can take a photo and we input questions to the model. As we can see, the model can answer the question based on our image. Yeah. And additionally, we can use the microphone to record the audio
large language
and
models.
have a voice conversation with the model. Yeah, the model can answer the question according to our input audio. In addition to model fine-tuning, LlamaFactory also provides data solutions. We have published a blog post on synthetic data construction with the Easy Dataset open source framework. Easy Dataset is a desktop application with a visual interface that can synthesize data samples for model fine-tuning. Developers who are interested can scan the QR code on the right to read in the full blog post. LlamaFactory has benefited from the open source community and is also actively contributed to it. Our GitHub project has received over 48,000 stars and has more than 100 billion, 100 contributors. On the Hugging Face Hub, there are over 6,000 models trained using LlamaFactory. During the development of our framework, we also submit dozens of bug fixes to the Transformers framework, which are recognized by the maintainers. LlamaFactory is still in rapid development. There are several new features we are working on. We have collaborated with the engineers from any scale to complete the integration of Ray, allowing users to experience the power scaling capabilities of the Ray trainer in LlamaFactory. We will also support sequence parallelism very soon, and hardware adaptation for Intel HPU is almost completed. You are welcome to keep an eye on our process. That is my sharing. Thanks you all.